Hey guys, what's up? It's Joe here. I make tech interview videos for YouTube, and today's problem is generate parentheses on Leetcode. What is up, guys? So here we go. Generate parentheses. So given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So for example, given n, the solution set is this, and so we can see from this solution set that there's always going to be 6 parentheses total, which will be n times 2. And we can see that 3 of the parentheses should be left parentheses and 3 of them should be right parentheses. And we can see that in the entire solution set here. And that'll be a prerequisite that we'll need to have in our solution set. So I just drew a diagram here to describe how we're going to be generating these. So we'll be starting off with a single empty string, and we'll continuously add a left parenthesis, then a right parenthesis, and then we do the same thing, left, or add a left here, and then add a right to this one. And then same thing, we just do that continuously downward. I didn't draw the entire diagram here, just because it would be very large. But this pretty much gets you the idea of what we're doing here. And so we can observe a couple things. So one, we can see that in this case where we have no parentheses here, and we add a right parenthesis, we see that the amount of left parentheses is less than the right parentheses. And in this case, we should just return, because we can never generate a good set once there's too many, or once there's not enough left parentheses in the string. As you can see here, there's not enough left parentheses, so this will always generate you a bad set. So we'll return out for that. Another case we can see here is that we see here we're adding 4 left parentheses, and we established that there should be 6 total in the set, which will be n times 2. So that leaves us only 2 right parentheses to add to this set, which won't be enough to actually generate a good set. So we can see here that here for left and right, so for left must be less than n, so the number of left parentheses, and the right parentheses must be less than n in order to keep adding and going to each side like we're doing here, where we're going to the left and then going to the right. Another third case here is the base case, where we're checking if n times 2 is equal to the current dot length. So essentially we're saying that if once we get to the bottom of all these branchings, and we get to the 6th layer, which is n times 2 being 6 here, and we have enough parentheses here, then we can say that just go ahead and add that to our answer. So we'll go ahead and start coding this out. So here we'll have our list answer, array list. Here we'll generate our sets. Answer, we'll start off with an empty string, and there'll be 0 on the left and 0 on the right for parentheses. And then we just return answer. Private void gen parens, and here we'll have integer n, list string, answer string current, and here we'll have our left and our right. And here we'll just follow exactly what we figured out, is that if we get to the spot where n times 2 is equal to the current length, then we want to say answer.add the current, and then just return. And then the next case we found was that if left is less than the right parentheses, then we can just return. And then here we'll go ahead and follow our next case, where we said if left is less than n, then we are good to keep generating parentheses, n answer Here we'll have current plus the left parenthesis, and here we'll take left and add 1 to it to keep track of the adding 1 there. And we'll essentially do the same thing for the right side, and we'll say +1 here. Take this out, and we'll make this a right parenthesis, and let's see how this is. So yeah, accepted. So essentially, like, if you just draw out this diagram, it'll be a lot easier to, you know, keep track of all this. And also we can see that for this question, we can look at the number of branches raised to the depth of this recursive tree, and that'll be our time complexity. So we can see here that we're branching off 2 times here, so in 2 directions, and this will be raised to the depth, where the depth is n times 2, because we're going here in this case, if n is equal to 3, we go to a depth of 6. So, and that'll be the time. So yeah, that's it, guys. Please like, comment, subscribe. Let me know if you want more stuff like this, and see ya.